don't view the 10-year vision as tied to any specific technologies, but really tied to a process that gets after the technologies that are coming out, the heavy technologies that are coming out, things like drones and robots and CNC machines and laser cutters and 360 video cameras and augmented reality, virtual reality, and whatever else comes out next. And so trying to get the school into shape so that we can be nimble enough to start to engage with those technologies as they begin to show up. The first initiative that we did was Vision 2015, and some of you may remember that vision. That was a 5-year vision. The large components were 24/7 reflective engagement of curriculum, moving learning outside the four walls of the classroom and teaching students to better use the tools they already use today. The way that showed up was to introduce light, intuitive technologies into the classroom. The iPad. I mean, this really symbolized Vision 2015 and the way that this might show up in a lower school classroom, and middle school language arts classroom, and upper school science classroom. To really think through this piece of technology, light, intuitive, online resources, Apple TV, so students can share their work with others. This new vision is going to engage much heavier tools. The way we tiptoed into it on the front end, we understood that with light tools for Vision 2015, we can hand an iPad to a first grader, or we can hand an iPad to our most senior faculty person. It's intuitive enough that they could, within a very short period of time, figure it out. With these new heavy tools, that's not the case, not even close. And so we recognize that students were probably going to be our leaders and really pulling the school forward in this area. I presented last year on 2 of the components that we utilized as we began to tiptoe into it, as we're interactive displays in our hallways. So we have maker spaces, but really trying to move engagement and creativity and some of the dynamics that can get after coding and robotics, moving those things into hallways so that they weren't so exotic, and students can engage with those in trafficked areas. And so as they're working on a coding project or a robotics project, other students would get to see that, other faculty would get to see that happening. We also have a Questworks program in upper school where students can apply for grant money to do whatever they want to do. If they want to build a drone, an aquaponics system, work on robots, work on, we have students that are making clothes, we have students, there's a wide range of projects. So those things we've touched on in prior PACA copies. Today, and I have Todd Martin and Tom DeVore and Mark Mitchell here to talk about these other components, the formal curriculums wrapped around some of these concepts, and our maker spaces, which just continue to be developed.
What I'm here to do is talk about the STEM initiatives in the upper school. So the nice part is I get to build off of a very solid computer science program that we've established here for a long period of time. And so about 6 years ago, we restarted the Robotics Club. And in the Robotics Club, we started out with big teams, big competitions, and this club is open to everyone in the upper school. It's an after school, during school type of club, and we worked on heavy tools, light tools, programming. We started out with groups as big as 30 that would work to build one robot, and we started out competing in the FTC tournament. With success, we went to many state championships. We never failed to advance to a state championship. And actually, believe it or not, our team ended up the Indiana state champion, defeating state champions from 5 other schools, or from 5 other states, I should say. We ended up that year going to, we advanced to the Super Regional of the United States, and ended up the World Tournament in St. Louis, where we finished as a World semifinalist, playing with teams from Russia, the Middle East, the Far East, and Europe at that point, and actually Central America was one of our partners as well. So the kids had a great experience with these programs. Now, we wanted to actually make that into a little bit more hands-on. We typically had 1 or 2 kids who were just the pure leaders of that group, and the other kids didn't have a chance to really learn as much as I wanted to. So we've since changed to the NRC competition. We can't win as many awards there, but the kids get a lot more hands-on experience in small groups. So now we work in small groups. We've changed our competitions. We continue to have a robotics club where the kids will make robots. This is one of them from last year. It was our first year in the competition. And we went there and saw, wow, okay, every first year in a new competition, you learn a ton. But I got to admit, even with this, it has a partner that looks just like it. We ended up being a semi-finalist in the Robo Hockey competition. In addition to that, we've actually had some initiatives put into the upper school. About 5 years ago, we started the Robotics Class. Now in this class, once again, it's open to all seniors, okay? It doesn't matter what your experience level, and we made it a point to make it very applicable. So I went out and researched what colleges were doing, what tools were they using in college, what could really prepare the kids to do problem solving their first couple years in school. So the school has been very generous with us, and we get to use SolidWorks, okay, which is a program which is used in almost every college, and it's also a program that's used in industry. So the kids go ahead, they learn the engineering design process, and they kind of get tested on it. It's 100% project-based though. There are no written exams. What they build has to accomplish certain tasks, and how they accomplish that task, that is how they're assessed in the class. One person who said, I didn't take this class for robotics really, I took it to do this other thing. She ended up making the Shakespeare's Globe Theater, which was really nice. And she wanted to make it for her club, for after school. It turns out she made 2 or 3 of them. She kept one, she gave one to someone else, and I have pictures of her actually filming the thing being on the 3D printer. So it'll self-design, and the Shakespeare one's up to the left, there's the temple, and then they're to the right. And the culminating project in this class, after they learn robotics, they learn some programming techniques, they learn how to draw things. What they have to do is they have to get in groups of 4 to 6. It depends on the year, how many people are in there. And they have a major project where their grade on their semester exam is based off how many points they score in a competition that I made for the year. The group that scores the highest points actually gets the 100 on the semester exam. And boy, you put that out there for an academy student. So that was the robotics class. So they learned some programming, they learned the CAD, and then they have project-based learning as a group, okay? In addition to their individual projects that they had along the way to learn the materials. And they can take these to college then. The idea is you're learning SolidWorks. I've had students come back and visit me and say, hey, Mr. Moore, this was great. I was actually tutoring the other students in SolidWorks. So I continually keep updated with what's going on in the engineering fields in college to learn what tools are they actually using. They allowed me to make another class that is purely project-based, and it's being implemented this year. And this one has to do with Arduinos and electronics and sensors is the name of the class. What it is, it's these little boards, okay? And in this class, I teach digital and analog signals, okay? So they learn the basics of electronics, how you communicate. And we go through a whole bunch of examples of how you do inputs and outputs. My final goal, really, in I don't know how many years to do this, it's going to take me until I learn how to do it, is to automate the greenhouse. Okay? To have the motors controlled by these little boards. Okay? To have watering, to have the temperature monitoring, to have it stored on the internet. Okay? And we'll get to that point, but the students are still learning some real basics here. So as long as me, as I continue to do this. I bring this project along because I've taught this class since the beginning of January, since we came back from winter break. It's a semester course. This project right here is actually an LCD screen, which I did not teach yet. This has not been taught to the students, but someone wanted to do their winter formal task. So if I actually plug this thing in, like the student did to their person they asked to the winter formal, it says, how about WinFo, Jack? Comes up on the screen. So the student just said, hey, I was having some problems with this. Can you help me out with this? He plugged it into his computer, looks at it, and says, yes. Okay. These projects here are upcoming for that. This is one that they'll make an app on their phone, and it controls this wirelessly through a Bluetooth connection in the car. So they'll be able to do that. How do I test that? They're just going to have to drive it through cones because they can do it any way they want. But how? They just have to figure it out by the end. This car here, they actually use a Wii nunchuck to drive it around. We're also going to have a gesture control car where you're holding a little board in your hand. And how you move your hand is how the car is going to drive. So these kids will go from not having this experience to 100% project rates and problem solving and having these at the end as their final assessments.
I have the benefit this year of overseeing the 2 maker spaces in school, the one located in middle school as well as the upper school. And it's just been amazing to actually have these spaces that are open, cross-divisionally, and I've had everything from 3-year-old program to seniors in there. It's a diverse space that can come in multi-purpose with, as you see on there, all kinds of big tools, whether it's the CNC machine, the 3D printers, the laser cutter that we got this year that was phenomenal, as well as a full set of woodworking tools and foam. Right now there's a freshman history class in there that's working on a project for world history. Yesterday, kids just came in and said, I want to make a nucleus for my 7th grade science project. Can you show me how to use design software? I want to 3D print. And these kids just walk in during their flex time or their advisory time. We have an entire advisory that come in and work on their projects. It's just they're amazing spaces. The kids can walk in the room with a thing in mind and say, I want to make this. I don't know how. It's a space where kids can we embrace their intellectual curiosity. We allow them to learn new skills, learn new tools. And the best thing I think of both those spaces is where kids can come in there and they can fail. And they can fail again, and fail again. And they can, I don't get this. Or learn something along the way. They come in with something in mind. They bring a poster board in for a project they have. And I have my poster board, then like, well, you could 3D print part of that, or maybe pretty laser cut the letters. Yeah, can you show me how to do that? The next thing you know, 10 minutes later, we show them the software, and now they're laser cutting their actual letters instead of just doing chicken scratch with There's 114 freshmen working on a project this week, and almost all of them have instant access to one of these machines. Most of them walk in the room having maybe some experience in some of the software, but some never have seen it before. 2 days later, they're producing high-quality items for their project, and get to walk away with that as a tool set in their pocket and say, you know what, now I know how to use that thing. Maybe I could do ... Maybe I could invite my girlfriend to the prom with this. If you just want to go in there and use spray foam and paint, we got it in there. If you want to go in there with a picture of the top, there's a student using actually 3D scanner that they attach to their iPad. He's actually scanning the student. And that becomes now a 3D rendering, which you can then 3D print. I actually have that's Jeff Forster. He was just sitting at his desk. A sixth grader walked in. Some people think he just, he was just sitting at his desk, and a 6th grader walked in the room and said, "Come sit still." And he walked around like this, and he brought it up, and we 3D printed a little Jeff Forster for him. He has never seen this one. This is my prototype. I'm actually going to make one life size. Not only did we create these spaces, both in the middle school library and one in the upper school library and middle school, but also the middle school's added free classes where kids can actually get competitive access to some of these tool sets. So both in 7th and 8th grade, so there's a coding class. Once again, this kind of scaffolds his way up to what Tom was talking about. So they do get access to the middle school to how we're going to use block coding, using Scratch, using some of the things like little bits or makey to actually create with projects, using loops and variables, and all the way up to using spheros, and just kind of getting that help. So I'm a 7th grader, I'm an 8th grader. Now I can actually code something. I can make this robot, I can make this device do something digitally. And then that's a tool set they have where they can apply to other things. In the STEAM class, the 7th and 8th graders also take, that's more of kind of like a real-life engineering class, where they might build a bridge that has to hold a specific weight. They make models of Mars rovers or lunar landers. They find out ways to clean up an oil spill. I think next year they may actually change that and try to clean up the big problem we're having with microplastics. So we give the kids a tub full of plastics and say, come up, here's your parameters, here's your constraints. Come up with something that actually, who in the room can clean up the plastics the thing at least amount of money and most efficiently. Those kinds of things happen in that class. Once again, getting kids to problem solve, to iterate, and to use the design process. The class I currently teach in 8th grade is called iDesign. It's a space where students can come in and really dive deep into the makerspace. So we I call it like a survey course of engineering, where we do design challenges, and then we work out our ways with cardboard. I give each student a cardboard Amazon box, and say make something. Other things in there we do take apart, where we give students old devices, and they take them apart and repurpose them to make robots. It always makes me sad when I give them a VCR to take apart and they have no idea what it is. I've had, honestly, of 60 kids this year, 1 kid said, "Oh, isn't that one of those things that plays the tape movies?" I'm so old. Someone was asking, how do they eventually end up using SolidWorks and making these robots? Well, we have to have an on-ramp for that. So Tinkercad is a program we use, Fusion 360, so these are CAD programs that literally take the kids a minute, 2 minutes to learn how to use. Kid walked in, this happened yesterday, kid walked in the room and said, I want to make a model of an atom for my 7th grade science class. I talked to him for 2 minutes. I said, create an account, click here, and he said, okay, I think I'm good. And he walked out, and he's now modeling in 3D space. He's going to come back today and 3D print it. Now, he might not have all the parameters right to make it 3D printable, so we might help him with that, but he's now on this, he's like, okay, I can do this. It's actually, I asked him, he said, have you ever used Minecraft? He said, yeah, I said, I think you're good. So he actually can model in that 3-dimensional space and stack things on top of each other and blend things together. It's phenomenal. We just give them access to these tools and kind of get out of their way and just kind of point them in the right direction. Students actually create furniture for the school. So right, if you go in the middle school right now, you see there's like wooden and metal shelves in the hallway. We made some shelving in the makerspace themselves. If there's a problem or someone needs a display space or needs help keeping their door open, the students will actually design a solution for the teachers around the school. And make the school a little bit better, and hopefully make something that they are long after they left. This was part of a senior English project. Students read a book, and then with some guy named Leopold, I guess, and made this Leopold bench. So they came in, and these benches eventually are going to be around campus. Some are going to be by the garden and the greenhouse, and others around the path. So it was a senior English class, and they came in for the day and made these benches that are high-quality benches. Every student was on chop saw and reading the plans. They had to use math, they had to use engineering, and work together as a team and create. I think they did 8 of them.
In the past, we've done Kane's Arcade, which I'll explain, Strawbridge Challenge, Toothpick Tower, Strawberries Challenge, Lego challenges, and then those are all unplugged activities that we've done. The plugged activities we've done are, right now we're just doing spheros, coding spheros. You can really try to do design thinking. And it's a mindset process for developing and teaching them how to think, teaching them how to create a solution, to innovate and to find solutions. Where it's used often in product design. Kane's Arcade is an amazing thing. It's our first project we did in 5th grade last year when we first introduced Makerspace. It's an amazing story about a boy who, out in California, during the summertime, didn't have daycare, so he would go to his father's auto parts store and was bored. Didn't have anything to do. But he had all these boxes full of auto parts that would get shipped to his father's store. And he just started to create. He started just to make small things out of cardboard. And then he's like, okay, he designed a game out of one time. And he's like, huh. So he kept going and building. He kept building different arcade games. The customer put it out on social media. Hundreds of people showed up. It's a great video. If you Google Kane's Arcade, it will come up in the story. It's really cool. So what we did, we made a challenge for the 5th grade last year. And these are some of the things that we came up with. I started teaching coding in the 2nd grade. The kids love it after a while. But it is a challenge, and most of the students really have an aha moment. They actually go, oh, okay, I get that now. But this is where we're using spheros, and in the 5th grade, they've already had coding since the 2nd grade, so they're fairly familiar with block coding.